Hi friends, in this video let us learn about the operation of PMOS transistor in enhancement mode. Before watching this, kindly refer operation of NMOS transistor, because if you know NMOS transistor, the operation for PMOS is exactly opposite to that. So watch that, then it will be easy for you to follow this video. Okay, in PMOS transistor we have to know something. PMOS is nothing but p-channel MOS, so channel should be p-type, substrate should be n, carriers are holes because channel is p-type. Okay, so this is a typical PMOS transistor. We know substrate should be n, and in the substrate we are having two heavily doped p region is p layer is formed, so it is p plus indicates it is heavily doped p region. From that we take two terminals. One terminal is called source, another terminal is called drain. Right. So as usual in MOSFET, metal oxide semiconductor. MO. This is yes. Okay. And moreover, it is enhancement mode, so no channel initially. Initially no channel. That is very important. Okay. So we have to enhance the channel. That's why it is called the enhancement mode MOSFET. Okay. What will happen? So from NMOS we know that when VGS is greater than VT, the current flow will happen and channel will be created. Like that it is PMOS, so it must be opposite. So when I give VGS is less than VT, so let us assume what will happen. The source terminal is always grounded. When you give negative potential to the gate, this is ESG, right? So negative potential to gate, what will happen? The negative charge carriers accumulate here, right? So this will create electric field. These charge carriers cannot flow through this because this oxide layer is insulator. But this charge carrier can create electric field because they are all static charge carrier. For a negative charge, the electric field will be like this. They are all coming towards the charge. So electric field will be like this. The electric field can penetrate a insulator. That is not at all issue, that we know from EMF theory. So the electric field will be like this. So for electrons and holes, the relationship between force and field is given by, this is for positive charge, this is for negative charge. So for negative charge carrier, force and electric field are opposite. For positive charge carrier, force and electric field are in same direction. Since electric field in this direction, the force for positive charge will also be in this direction. So n-type substrate has only positive charge carrier as majority carrier. So what will happen? These majority carriers are pushed towards this region, the region between the source and the drain. Not here. So especially here it is minority only, but here p-type it is having a lot of holes or positive charge carrier. It is also having a lot of positive charge carrier, majority carrier holes. So this force will push all the holes here, right? But still there is no path for the holes to travel. So when you give small VSG, the holes will be pushed between source and the drain. There will be holes, but no current. When you increase VSG and apply VSD, this is D, negative VSD. When you apply negative VSD, why I put it is VSD is because source is ground, so it is VSD, VS minus VD, 0 minus VD. So VD simply minus VD I can write as VSD. So minus VD I apply, what will happen? Then the potential difference exists between source and drain. Then when you increase VGS further, then lot of holes from these two heavily doped regions are attracted towards this part, region between these two. So when VSG is lesser than some VT, when VSG is less than some VT, right? So beyond some VT, the channel is completely formed and the current starts flowing with the proper VSD, right? So the value of VSG at which the current flows is known as VT, right? So then only the current starts flow, otherwise there won't be any flow. This is exactly opposite to, so what you call NMOS transistor. So here VT is negative value because VSG is negative. So what is VT? It is the value of gate voltage, at which current starts flowing in PMOS. That is known as VSG or VTP. It is a threshold voltage, VTP, right? So this is very, very important point. So when you are having sufficient amount of VSG and VSG crosses VTP and we have a VSD that creates potential difference between these two, then we are having a flow of holes from P to N region. So drain current holes flow will be like this. So current flow is from source to drain. Conventional current flows from source into drain, right? So this is called drain current. Okay, so these are all the points we have to remember, and you see VSG must be greater than 0. VSG must be greater than 0 indicates what? VSG, I can write VS minus VG. So VG is negative, then only we know VG is negative for PMOS transistor. Now only we have seen, right? Because when you apply negative potential, then only we are creating the channel. You see negative potential, then only we are creating channel of holes. So VG must be negative, so VSG must be positive. That is one important point. Similarly, VSD, that is also greater than 0 because we know VS minus VD. Vs is 0, Vd is negative means then only we will get positive. Why it must be negative Vd? Then only we will have a flow. Because then only if you have a negative VSD, then only there will be a potential difference will exist and the holes will be attracted towards this region. Right? So that is the reason VSD must be positive. VSD must be positive, but the voltage at the drain terminal should be negative. That's what we have studied, right? So right, what is the other purpose of this negative VD? So this negative VD induce electric field. So this negative VD or ESD greater than 0 induces electric field. This will only force, this is electric field. This electric field force to move from source to drain region. This electric field forces holes to move from source to drain. Right, so that is a point. Right, so because of that only we want VSG must be greater than 0 and VSD must be greater than 0. This indicates VG is negative and VD is also negative. Right, so these points you must remember whenever you work with the PMOS transistor in enhancement mode. So from this we understand what VT should be negative. So in PMOS the main conclusion is VT is negative, current due to holes. We know in MOSFET current is due to majority carrier, right? So this is one point in PMOS and enhancement model, no channel at initial stage, right? So at the VTP only channel forms. Okay, so that is another point. Fifth point is then what other thing you have to remember, substrate is N type. it is empty. So these are all the points you must remember whenever you work with the PMOS in enhancement mode. Thank you.